Okay, so we're still on S6, question 16, and now we're down to the last 3 questions. So just to recap, we've answered these first 2, and now we're going to answer these next 3. So I wrote them down here, and I recopied my picture, so then I could have a fresh start here. So how many boxes weigh less than 23.188? Well, I'm going to draw a new line, 23.188. That's way down here, okay? And way less would be on this side, and way more would be on the other side. So I'm expecting this to be a fairly small number of boxes. So the first thing I have to do is calculate that z-score, 23.188 minus 24 divided by 0.28. Now notice that my z-score is going to end up negative because this value is less than my mean. So don't be surprised by that. So I'll go to my calculator again to calculate these things. So 23.188 minus 24 divided by 0.28. And I get negative 2.9. That's a really low z-score. Remember, 99.7% of our data falls within 3 standard deviations. So this is right on the edge here, okay? So I need to go to my z, and I'm looking for negative 2.9. So negative 2.9 is right here. So this is the number I want, 0.0019. So if you think about percentages, that's 0.19% that is less than that number of ounces. Okay, so let's 0019. So that's on the table. The area to the left is 0.0019. So I'm going to take that and I'm going to multiply it again by that 880,000 boxes. Okay, so go back to Desmos. I'm going to take that 0.0019 times 880,000, and I get 1,672 boxes. At this point, you've answered that question up here. So 1,672 boxes. But now we need to find the ones on the other side, right? So now we want to find the ones over here. How many weigh more than that? I could use either option 1 or option 2 from the video above. I'll do it option 2 so you can kind of get used to using that. So on your Z table, it's area to the left. So if I want the area to the right, I need to do 1 minus that value. So I'm going to do 1 minus 0.0019. And I'm going to get 0.9981. So that means 99.81% of the boxes are bigger, or way more, I should say, than 23.188. Now, I am going to show you something very interesting. Z table. If I went to positive 2.9, do you notice how that is 0.9981, and that's the number I'm looking for? So when it was negative, it was the area to the left. When I looked up the positive value, that would be the area to the right. Irregardless, I need that number, 0.998. So I'm going to take that 0.9981 times 880,000. I'm going to go to my calculator. And I get 878,328 boxes. And that's what my answer would be to that fourth one. 878,328 boxes. Now, here's the real gotcha, is we need to find the weight between these two. They did it on this problem because you've done all this work so far, so you have some of these answers already. So remember when we did 23.188 and 24.182, we got those areas to the left. And so I'm going to show you one more picture. Do this. Okay, and I'm going to bring this down here so we can see the area between them. So I'm going to go back. So we already had the area to the left there. If we go back to that very first picture where it was 24, what was it? 24.182. 24.182, so it was about right here. It's a different color there. And we shaded all the area to the left here. Do you notice, maybe that one was too dark. Well, let's go here. Let's shade this yellow because we already had that. And that value was negative 2.9. Do you remember that? And this value was 0.65 on our Z table. Okay. And let's shade to the left here all of this. Do you notice that I've double shaded this area right here? So I don't want that included. I really just want this area. And remember when I was at negative 2.9, my area was 0.0019, and my area here was what was it? I can't remember. Oh, right here, this 0.7422. So 7422. So that is this area right here, all in the green. This is the area in the yellow. So if I want to find the weights between, I'm going to subtract those two. So 0.7422 minus 0.0019, and that's going to give me the area between. So I'm going to subtract those on my calculator. 0.7422 minus 0.0019, and I get 0.7403. Now I'm going to take that value and multiply it by that same 880,000 boxes. So you can see these problems are very involved. So you get 651,464 boxes. And that's our last answer that we were looking for way up here at the top. So we get 651,464 boxes. So I know this is a long problem, but I hope this helped you see, and I really draw my pictures and show all my work. Thanks for watching.